training. But since not everyone is here yet, we give them another 5 more minutes, right? So we will wait for another 5 more minutes until 9:35, then we will go into the training. So in the meantime, does anyone have any issues with licensing or trying to access into the software? And at the same time, have you guys downloaded the live online training guideline? I could not download the guideline. The website is undergoing maintenance. Is it anyone else having this issue? Not able to download the guideline? If no, I can straight away send the file here to you all. Anyone else having issues trying to download the guideline? Okay, so I've already attached the guideline inside the chat box. Can you find the guideline there? Okay, great. You can download from the chat over here. It's the same thing. How about licensing? Anyone having any licensing issue? Unable to open the software, things like that? Or unable to get the TRB software, unable to download things. So if we try to settle it before we start the training. Yeah, there's still people coming in slowly. (9:35). We'll start at 9:35. Okay, it's 9:35. Has everybody downloaded the guideline? Because inside the guideline we have a lot of contents and links where you can find, for example, like the software. Then after that you have e-community and things like that. So it's important for you to download the guideline because there are certain elements inside there that you may need to use. Right. So without further ado, let's start with our training. Now, the first thing I like to talk about is always a live online training guideline. Why? For calculation rules, we are gonna have 5 items over here in this guideline first. Let's talk about the guideline first, right? So the first one will be enrollment to e-learning, downloaded installer, materials, sign up to e-community, and e-certificate. So a lot of things here that some of you may want to go through. For example, like why I want to talk about enroll into e-learning is because when you go into e-learning, there are much more courses inside there where you can go through, right? Instead of just calculation rules, we also have site label training, then we have TRB intermediate, TS intermediate, so on and so forth, right? We also have installers where you can actually download inside there for TS and TRB. So for example, now we are doing calculation rules. So the installer here that we will send to you by link is actually TRB. Same goes to materials. Right, we will have materials for you to use. So make sure you go through inside the materials here. Later, I'll show you what kind of materials you have. If you did not download any materials, you can go and search the materials later. Then after that, we have signing up for e-community. Our e-community is going to be our service hotline platform. Last time we were using this WhatsApp, but it was not very effective because it does not keep any trace or any history well. Right, so when we want to look for history, it's a bit difficult. So we are shifting towards this e-community. And after that, we have e-certificate, which is if you want to apply for a certificate, intermediate certificate, you can try to go for this e-certificate. Now, let's talk about e-learning first. When you go into this slide, live online training, there is this button where you can actually click on, loaded MY e-learning. So it will actually bring you to this page. It's actually undergoing maintenance. But never mind. So what you need to do is you can actually sign up to this e-community, right? By going to Learning on Demand. There's this small button at the bottom. You can scroll all the way to the bottom. It's at the bottom corner. You call it Learning on Demand. Then after that, you need to choose the course, right? Calculation rules course. And then under calculation rules course, you will need to download you will need to apply this coupon mini course because there is a 650 ringgit. This is to prevent simply anyone from coming into the e-learning platform, right? So if you are attending this training, you can straight away put in this mini course and you can get the access into this mini course calculation rules. There are downloads and materials inside here, so you need to get inside this e-learning. But if you don't have, never mind. I will send the contents to you via this chat over here later, so it's fine. So you need to sign up for an account first before you can actually use e-learning. So make sure you sign up for an account, right? And then you can go through this browser curriculum. So you can read through the things inside there, right? So if you go into e-learning inside here, make sure you're inside Golden MY, not ID or Singapore, right? Because each and every one of these country over here has different contexts. So what we're doing right now is for Malaysia. So make sure you're inside Golden Malaysia. Okay, to download the installer, you need to go to course requirement if you can access into e-learning, but unfortunately now we can't access into e-learning. So just to give you a heads up, if you want to download the contents or installer, you can go to requirements. After that, just click on the installer button over here. Right, then there is a guideline inside there where you can follow, but actually installation is very easy. You just click install, next, install, next, and then it's good enough already. Then after that, for materials, you need to go to course guideline. So inside course guideline, you will have a set of slides inside there for you all to refer to. So even if the training is finished already, you can go back there and refer to the slides, right? It's completely free. You don't have to pay for anything. And then after that, we also have materials. For example, if today we are using a certain materials for calculation rules, then you can download from that, right? I mean, it's not compulsory to download right now, but you can download it after the training if there is use. And lastly will be the feedback form. In order for you to get the recording of today's session, make sure you fill in the feedback form, right? Because this feedback form will be used to improve our software, and at the same time, we're used to improve the training as well. Then after that, we're moving towards the end already, which is signing up to e-community. So if you have a lot of questions or queries, we are no longer using WhatsApp anymore. So make sure you sign up for e-community. To those who are not familiar with e-community, what e-community actually does is that it allows you to ask questions inside there. So let me show you what do I mean by e-community. Okay, so let's go into e-com. So inside e-community, why we want to use this is because there is traces and tracking inside here. So for example, if you have questions about, let's say RAM, you just need to type in RAM, and then answered questions will show up, like how to draw RAM according to drawing without RAM element, gradient floating RAM. After that, we have topological errors on RAM, sloping slab RAM. You can click into either one of these, just click inside, and then people will ask questions. And at the bottom there, you will see someone answering over there. It will teach you how to do it, right? And then if you still have any things or doubt about this answer, you can just put inside the detail inquiry and continue asking. It's like a chat box like that, right? So we want to use this is because we have traces of things that we have asked and things that people have answered you, right? So it's important for us to get into this e-community. Let me show you. So for example, I want to look at my history. I can go press on this button over here, and then I can look for the questions history that I've asked before. Right? These are the list of questions that I've asked before, and a list of answer that was given by me to another person. Or if you have a favorite, you can put inside favorite here. Right, so the reason why you want to use this is because there's good tracking. It's easy for you to look for all these items, right? You just need to press on it, then it'll bring you directly to that question over here. So this is how it actually helps you. Okay, so this is for e-community. Right? The signing up is actually very easy. Just click on sign in over here, and then you'll bring it to this sign up register page. Right, so you just put in your email, your password, confirm it. Then after that, you should be able to use the software. You should be able to use the platform already, right? And then the last one is e-certificate. So if you intend to take your intermediate certificate, you can actually register through this live online training guideline, right? So once you have already get this guideline ready, you just need to click onto this photo over here. But it's undergoing maintenance currently, and then there is a button for you to click, which is QBCon certificate. And then you can check your certificate over here. If you have already applied for basic training one, or you have already done your basic training, you want to get your certificate, you can check. Just put in your name and your date of birth. You don't need to put in the certificate number because we don't know that, right? So just put in your name and date of birth, and then you should be able to get the certificate. And after that, we have intermediate certificate. So this intermediate certificate is open to all. You don't need to have a basic training certificate, right? You don't need to have the basic training certificate. You just need to attend the intermediate training. And then after that, when you have completed a project by yourself, you can submit one actual project, which is about 5,000 meters square like that. And after that, pass an online evaluation on the project which you have already submitted to us. We will ask you questions relating to that project, right? It's not going to be hard. It's going to be quite simple for intermediate level. So don't feel free to ask me anything about this intermediate certificate later on if you have any inquiries towards the end of the training. Okay, so that is all for live online training. Any questions so far? Does anyone have any questions? If you have questions, just ask the question directly inside chat box. If no, you can just put no so that I can proceed to the training. Yes, no, anybody there? No. Okay, what about the rest? Everybody, am I okay to proceed to the training? No, okay. Okay, the others are not saying anything. I don't think I can wait too long, right? So I'm just going to proceed if you're not saying anything. Okay, thank you so much to those who have answered me. Right, let's proceed to the training. So today's training will be about calculation rules. So a lot of people ask questions about calculation rules, but yeah, because they don't really know how to use it. So in this particular training, we'll learn how to use calculation rules and how to read the information inside calculation rules. So be prepared, right? So let me introduce myself a little bit first. So my name is Kin. So full name is Ng Su Kin, but people usually call me Kin now, Mr. Ng, right? So if you have any queries, you can directly contact me through my email over here, right? If you have any other queries related to this calculation rules one, you can email to me or you can directly ask me inside the chat box. So no worries about that, right? So just a small introduction on myself. I'm a service consultant here in Golden Software, Sdn Bhd, right? I've been giving trainings and project guidance technical support for the past year because previously I was from another consultant company. I was with RLB, QS consultant for about three and a half years like that. So I've been working with them. So I've decided to move on to software is because I want to teach people how to use Golden because I realize a lot of people, they just use the software, but they don't really understand the concept of the software. So my dream is to actually teach people and make people understand about the software. So I'll try my very best to help everyone here understand calculation rules because to me, I think that's one of the most important topics in TRB, right? So if you have any further questions regarding certificate or any other account related things, right, you can email to service-my@global.golden.com also. This one is our main service email, right? Then after that, so for support assistance, like just now, you just need to attend, you just need to go into e-community, Golden, that's all, right? Okay, so I have some few what do you call that, ground rules over here. It's not strict one, it's just ground rules so that people can follow. The first one is I need you all to listen to the training until the end of the session, right? So you need to make sure to mute your microphone so you don't distract other attendees, right? Not to say you cannot ask questions. You can ask questions. If you have questions, you can leave it inside the chat box so that I can answer you. I'll use my voice to answer you. I won't type it out, so don't worry about that. So if you have any question, just leave it inside the chat box because I have one eye looking at the chat box, the other eye looking at my screen so that I can teach you, right? Then if you need a recap, you can always ask for the recap inside the chat box. I'll repeat, it's fine. I'll repeat so that until you understand, okay? And then the last one is be open-minded because if you are transitioning from manual measurement to software, we need to be very open-minded. If you are not open-minded, it's very hard for us to absorb today's training, right? So this one is our e-community. If you want to register, you can directly register inside here or you can refer to the guideline later. Okay, I have some training contents I want to share with you. Today we are going to talk about 8 chapters. Chapter 1 is Introduction to Calculation Rules. Chapter 2 is going to be about column. Chapter 3 is going to be about walls. Chapter 4 is going to be about slabs. Chapter 5 about foundation, Chapter 6 about ground beams, Chapter 7 about masonry structure, and Chapter 8 about others. So can anybody tell me what's missing from the contents here? What elements is actually missing from the contents here? Come on. I've seen some familiar face that has actually attended my other trainings. I think you should be able to tell what's missing inside here. What's missing inside the training content? I need to let you all know first the things that are not inside here so that you understand why. And you don't ask the question later. Don't know? Yes? Don't know? If you know, then you just tell me what's the element that's missing. If you don't know, you just put don't know. So I know that you don't know, then I can tell you what it is. One piling, we got one frame beam. Okay. Actually, piling is under foundation already. We have piling. And Boon Xiong, yes, you are right. Frame beam is not inside here. The reason why frame beam is not inside here is because we have one calculation, site label training that has full coverage on calculation rules for beams. That's why we don't have it inside here. We don't want to duplicate the training. So for that particular item, will not be covered inside this course, right? But we will be covering ground beam because there are certain things inside ground beams that are slightly different compared to our site label over there, right? So we won't have frame beam in today's training. But if you really want to learn about frame beams, you can go into our site label training, right? Okay, we must input item data on BOQ frame. We are not going to talk about BOQ frame or anything today. It's more onto our TRB software elements, right? How to set the calculation rules and things like that, right? Okay, let's not waste any more time. Let's go straight into chapter 1, Introduction to Calculation Rules. Now, I understand that some of you have actually used calculation rules, but there are some people that they never really touch calculation rules before. They enter the training, they enter the project file, and then after that, they start modeling without doing anything to the calculation rules. And when the reinforcement bars are not right, then they start asking questions, hey, how come my reinforcement bar is like different from my drawings one? It doesn't look the same. Okay, the reason why that happens is because you don't have calculation rules. You have not set any of the calculation rules inside your project. Each and every one of the project will have a very separate calculation rules and method, and it depends on your general notes. So the thing about this is that we need to understand why we need to have general notes and why do we need to have calculation rules, because we have many, many different kinds of settings, right? So as you can see over here, in order to open your calculation rules, is very simple. Just create a new project first, right? You can go into project settings, calculation rules, and then you should be able to see the whole prompt over here. The whole prompt over here, you will have column, walls, beams, slab, foundation, ground beams, masonry structures, and others, right? So these are the things that you will see inside here. And then in order for you to use the the calculation rules, you must first be able to access your general notes. You need to understand what you want to do with your general notes first. So read the general notes first. Just like any other manual measurement, we always read the general notes first. We need to understand what are we trying to do with the general note, right? Before we apply it into the calculation rules. Then only go into understanding TRB and general notes, combining together, which forms into calculation rules, right? So we don't want to simply fill the information inside calculation rules. We want to make sure that everything from general notes is transferred into calculation rules. So we need to understand those concepts over there first, right? But of course, I'll bring through you each and every one of the elements, those commonly used, but I won't bring through everything because it's going to take more than one day. But I will bring through to you those commonly used calculation rules and things that you should check. Just some additional information for you all, right? Now, let me talk about calculation rules inside our software. When you click into calculation rules, we have column, we have wall, we have beam, we have slab, we have foundation, we have ground beams, we have masonry structures, then we have others also, right? So in this particular calculation rules over here, usually we will have column, and then we will have one common setting. Right? The common setting is for very general calculation rules or general notes based on your column. And after that, we have anchorage of your top column, right? We will have anchorage of a top column. We will have anchorage of your bottom column. We will have section change conditions, and we will also have wall column. Now, a lot of people don't know what the small column means. In Malaysia, our term is called shear wall. We don't want to call it wall column because wall column is actually a terminology from China, right? A lot of things, TRB, TAS, we actually convert from China into English here in Malaysia. But those certain things that you don't understand, don't worry, because I'll be here to explain to you all those items. Don't worry about that, right? So up to this stage, for calculation rules chapter 1, is everybody okay? Because chapter 1 is just an introduction and it's very simple. Everybody okay? If okay, please put an okay inside the chat box so I know that everyone is able to follow. Okay? Okay. What about the rest? Everybody can follow? Don't worry, today's training we won't have any quiz or anything, but we will have one small exercise towards the end. PB is okay, Amy is okay, Goop is okay. So I would say majority is okay lah, right? Now, moving on to chapter 2. Chapter 2 is a much more interesting thing. I always like to talk about column because column, I don't know, I just like the visual of column, right? So we're going to chapter 2. Let's talk about column first. So basically speaking, when we talk about calculation rules, let's go into the TRB first. Where's my TRB? Here. For the new file. Let me open up a new project. So what I'm going to do in chapter 2 right now is going to show you important things that you may touch, may use during your project execution, right? Let me show you. Okay, we go to project settings, right? Project settings and then calculation rules. So under calculation rules here, you can see this is actually my column calculation rules setting. We have 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 items inside one common settings. This is the common settings that I showed you just now, right? So these are very common settings that you can find inside calculation rules. And then we also have anchorage of the top column, anchorage, right? There are different conditions like middle column, outer bars, inner bars, transfer column, and then no joints. You also have bottom anchorage of your column to your beam and slab, or maybe to your walls, right? If your column is sitting on your wall, then it's actually applying this condition. If it is sitting on a pile cap or any foundation like rough foundation, strip foundation, then it will be sitting based on these settings over here. And after that, we have on pile, we have core column, section change, no joints, wall column, right? So I'm going to go through these items with you inside the slides. Okay, so the first one I want to talk about is staggered distance. Now, this staggered distance, just to let you all know, we have 3 types of staggered distance. The first one is the one that we are currently using all by default, right? Which is 100%. Means the staggering will be synchronized with each rebar. Then after that, we have 50%, which is both staggering will be, one is full 100%, the other one is 50%, 100%, 50%. So we make it in such a way that there is 2 different staggers, right? Then after that, we have 25%. So all the staggers will be different. It will go down 1, 2, 3, 4. So the rebars will start going from top, middle, and then bottom. So we have 3 different sections over here. Now, let me show you what do I mean by staggering inside the software. Easier for you to understand. So assuming I'm going to put a column over here. Let me put 3 different columns first. Put 3 different columns. So I'm going to copy this to another floor. So just now what we did was the staggered distance. So the first one, I'm going to use the original one, which is at 100%. And then I'm going to use the second one to put it at 50%, right? So I'm going to select the column and adjust the changes inside the calculation rules here. So the staggered distance for this one, I will put 50%, right? 50%, and just press OK. And then the third column, I'm going to put 25%. 5%. I press OK. Then after that, just calculate the columns. Let me show you the differences between these columns later. All right, so the first column that we are seeing right now, the reinforcement, you can see that this is at 100%, right? Very steady. Everything is like very synchronized. Maybe let me put front view, then it's easier. Okay, everything is very synchronized, right? But if we look at the one on the right, which is 50% one, it's actually staggering. This one is actually staggering. So you can see over there, it's actually staggering. Right, 50%. Remember, just like I say, some of it, one bar will be 50%, another bar will be going up at 100%, 50%, 100%, 50%, 100%, 50%, 100%. So this is the situation if you are placing 50% staggering. And if 25% staggering will be much weirder. For every reinforcement bar, it will actually stagger by 25%. So every 4 reinforcement bar, it will stagger and then go back down to 100%, and after that to 75%, 25%, then 50%. So this is how we actually change the staggering. But I would say that this one is not commonly used, but we have seen staggering information like this before, but not commonly used, right? Usually we just leave it by default. This one is good enough already. Lapping would look like this, because usually only on special occasions will you use staggering 25%. Even for 50%, also same thing. Special occasions. Maybe if you're working on a highway, you're working on a pier, then yes, this is actually quite common, right? Stagger. So for staggering, is everybody clear? Is everybody clear with how it works? If clear, just put a yes. If no, then you can put a no over there so I can repeat again. Yes. Okay, great. So if I don't see a no, I'm going to assume that everyone is saying a yes. Okay, now let's move on to the next item. Kicker and links. So basically speaking, when we talk about kicker and links, a lot of people also get confused. Sometimes they don't know what is kicker, because in certain drawings like general notes, they don't tell you this is kicker. They just tell you that they just highlight this part over here, and after that they put a 75 mm, but they don't tell you what is the item over there. So certain people don't know what the kicker means, right? So kicker is actually the spacing between the reinforcement bar on the columns at the floor above and the column below, right? So there is a gap in between one, near the lapping over there. So that is actually called a kicker, right? So the thing about this is that how do we actually set kickers, right? So if you see in the diagram on the right over here, you will notice a lot of things like column seismic, column non-seismic, wall column seismic, wall column non-seismic. So maybe I explain to you a bit first what seismic and non-seismic means. So like countries in Malaysia, we are considered non-seismic countries, right? Because we don't really have earthquake here in Malaysia. Even if we do, also we can't really feel it. It's too mild for us to feel those kind of earthquake. But like countries like Taiwan or Indonesia or maybe Japan, those big countries, China, you will have this kind of situations where you need to have seismic development, right? So in the project, in the very beginning, we usually set whether the project is seismic or what. But in cases like this, Malaysia is not a seismic project, so we don't need to use any seismic information, right? We are not a seismic project. So by default, we leave it at non-seismic one, unless otherwise you are dealing with other projects away from this country, then you change it to seismic, right? We have different grades. So in cases like this, let's talk about kickers and links over here, right? So the situation is this. When we talk about the kickers, how to actually set the kickers is you need to know which one you are planning to set on, right? We have column, we have wall column. If you are intending to set to all the columns that you're currently using, then you should always choose column non-seismic, right? This is 75. But usually we don't change 75 because most of the time general notes will show your general notes. I've seen so far all the general notes, it's always 75. But the kicker is nothing more than this 75. But if you really need to change, you can change inside here, right? 75. But this is for column only. If you intend to change for your shear wall as well, then you need to change for your wall column, right? So we have two items. Remember, wall column is for shear wall, column is for your regular column. So this is called kicker. You can actually find this inside your calculation rules. Under calculation rules, under column, then you can find the item over here. You can just click on it, then you just change it, right? You can just change the figure, like if it is 120, then you just put 120, things like that, right? So if you want to reverse it back to default, you can just right click on it and then restore current setting to default. Yes. So that's the situation. Now, here in this column non-seismic, you can also set whether you want to, if you are using lapping, then it's 75. If you are using welding or mechanical, then it's another figure, right? But most of the time, we don't really mix lapping or welding and mechanical one, right? It's either you straight away use lapping or welding or mechanical. This one is only on special occasions where you really need to change. But so far, I've never had anyone asking me about this, whether you can change or not, because I think in Malaysia also it's always just one type of lapping. Different lapping also will be mentioned specifically for that column, then we can entirely change the whole thing, but it's totally fine, right? So column non-seismic, remember that? Wall column non-seismic is for shear wall, right? Remember that. So where to find the wall column, if you want to know, is actually under wall. And then you can find it wall column here. So basically the functions is exactly the same as column, just that we categorize it out separately so that you don't need to mix it with your column. You can have two separate items between your column and your shear wall, right? So usually shear wall, we use wall column withdrawal. This is one information for you all to know. All right, then we move on to the next part, which is links inside the densified zone. So when you want to key in your links, right, there are certain places where you have different kind of links. One, what is actually densified zone? Okay, have anybody heard about this densified zone here in Malaysia, or any particular project where you have? Okay, how about this? Any particular project where you have, for example, this is your column, and then the links at the purple square that I just draw over here is much more, how to say, compact compared to the one in yellow here. Has anybody seen a column that looks like this? Purple color is densified zone. Yellow color is non-densified zone. Anyone seen this kind of drawings before? No. Actually, it's not common here in Malaysia, but it's very common in Indonesia or China, because this actually saves a lot of saves a lot of money, right? Whatever they need to, I mean, it is very accurate type of settings for your column, where you can actually change it inside the software. Here, you can actually put your links inside the densified zone also. You can set inside here, for example, the spacing of links at the lap zone of the links inside here. You can actually change it at the top part, right? You can change at the top part here and the bottom part. But for example, like this densified zone that we want to change, that we are talking of just now, let's go inside the calculation rules and have a look. Okay, so assuming that I have densified zone, the D zone over here, this is my densified zone, right? So you can choose the length you want it to be. For example, what I'm trying to say is that the distance or the range from here until here, how much do you want it to be? So currently, Hn divided by 4 means the height of the column divided by 4 is the range length. So if you want to change this, you can directly key in the range length over here. For example, if it is 400 mm, then you just put 400 mm, which means the top part here, the densified zone will be 400 mm wide. The bottom part will also be 400 mm wide. But assuming if you have to change, if the top part and the bottom part is both different, right? The densified zone for the top part and bottom part is both different. You can actually click onto these 3 dots over here when you press into the button there. And then you can choose the top densified length. If it is 400, then it's 400. But if the bottom densified length is different, like for example 800, then you can just straight put 800. Or if you have a specific coding which is given to you, for example, okay, for example, here it says that for your top densified zone, inside your general node, it says that it's supposed to be 1 out of 5 of your height of the column. Right, so you can type 1/5 times HN. Oops. HN divided by 5, sorry. Okay, you can put in HN divided by 5, which means that this one is actually 1 out of 5 of your height of the column, right? Then maybe your bottom densified zone is different. Your bottom densified zone, you say, is 1 out of 4 instead of 5. Then you put 1 out of 4, HN divided by 4. Right? Or if you have a different code which you want to use, the software tell you it depends on the diameter of your reinforcement bar, it is 40D. Then you just put 40 times D lah. You can follow the prompt at the bottom over here. It teaches you how to key in, right? You put 40 times D. Can do this also. You can change this also. But if, let's say, for example, your top and bottom densified is different, right? Now it's the same. It shows 40 times D over here. But if it is different, then it will show you that this is actually calculated by settings. So if you want to change the information over here, you can just click here, directly click inside here and change 400 mm, something like that. Or you can just go inside these 3 dots and adjust inside here. Also can. Totally up to you. Right, so this is how you adjust your densified zone for column and wall column. Same, right? Just that we categorize this differently so that you don't have to use it all the same, right? So for your column and wall column is different. You can adjust it separately, right? So this is for densified zone. Now, let's move on to the next one. Densified zone link. Okay, this one. Spacing, are the links at lap zone densified? So for example, what does this mean is that, okay, if you have a lap zone over here, do you want to consider this as a separate densified zone? Or a separate densified specifically to your links? Like for example, there are certain situations where general nodes will tell you, okay, I want your densified zone links to be much more compact, right? So you're going to change this to yes. So at your lap zone here will be a separate densified zone. And then after that, the spacing of your links, you can directly put it inside here. For example, if it is 200 mm spacing, then you just put 200 mm spacing, for example. So the spacing will be categorized in the center over here, right? So this is spacing for lap zone, but this is actually very rare also. Just to show you that you can actually adjust inside here, right? You can adjust inside here. And then, now, just not what I show you inside was calculation rules. But do you know that inside your column, you can manually adjust here also, densified zone? Just select your column, and then you can see that there is top densified, bottom densified. So you can see just now 40 times D and 400 was the item that I've set inside calculation rules. So it will automatically apply to everything by default. And then how to know whether it's applied by calculation rules or not? You have to check here. You can see that there is bracket. If there is bracket, means it's automated from your densified or your calculation rules over there. So that is the situation, right? Just to let you know, this is additional info for you. I'm not supposed to go until this part one. Just supposed to talk about calculation rules today. Now, I won't show you too much on general notes because I want you all to get the concept of the calculation rules first before we go into general notes. That one is towards the end to see how your understanding goes, right? So up to this stage, for kickers and links, everybody okay? The slides here. Is everyone able to follow the slides here? Okay, good. No, yes, yes, no. If no, please let me know. Please let me know if you don't understand because I need to. I will repeat again. I will repeat again so that you all understand everything. I don't want any of you to miss out any important points. Okay, looks like everybody is saying yes. No problem then. Right, then we go on to the next slide, which is different size column. So this one is also very commonly used. You can actually find this in most of your general notes. So when we talk about different size columns, what does this slide actually tell us is that now the settings here is to tell you how you want to lay your reinforcement if there are variations in section, right? For example, the column here and this column is different in size. So this is what the software is trying to tell you. What happens if both of these column size is different? What should happen, right? For example, if my bottom column to my top column is different in size, it will apply this type of reinforcement, which means that my reinforcement from the bottom will go all the way up towards the end, bend in. Same goes to the other side, go all the way up, bend in, and then after that, for the column in reinforcement from the top over there, you will have a starter bar that plunges inside. This starter bar will actually poke inside the column at the bottom, and then you have links here. So this is what it's trying to tell us. Right? This is what the software is trying to tell us. This is what's going to happen if you apply the settings for when your offset is more than the set value. So offset is the side over here, the distance from the dimension of the small column on top to the bottom, right? How far is it away from each other? So if the offset value is 75, let's say, for example, if the difference is more than 75, then it will actually apply this function, which means that if the column on top is too small, the column at the bottom is too big, so you can see that it's more than 75 in differences, then this is what's going to apply. But if it is less than 75, the offset value, right, the sides over here is less than 75. If the offset value is less than 75, then it will apply this particular settings over here. So we really need to understand this situation. If we don't understand, then it's going to be very difficult for us, right? We need to understand this situation. So this is where you actually fill in your offset value. Check your general notes. What's the offset value? Usually general notes will tell you the offset value. But why we put 75? Because this is actually the most common things that you see inside the software, which is once it exceeds 75, then different kind of settings will be set up for a different size column. So I think this one is quite straightforward, not too difficult, right? You can also adjust the links arrangement within your band or buried section, right? So this tree over here, the link arrangement, you can actually change how many links you want it to be inside this tree part. You can change it. If you don't want it, then you just put 0. If you want it to be like 3 links inside there, 4 links or 5 links, additional links inside there, then you just put links arrangements inside there, right? So you can find these settings inside calculation rules under here, right? You can change the offset value over here and always read the note below here. It will tell you what kind of items you can actually key inside, right? You can key in this information inside here. So make sure you always check. When you click inside the button over here, it will tell you what you can press, what you can do, and what you cannot do. So it's very important for you to read the information inside here, right? Okay. So for different size column, everybody okay so far? Able to understand the concept? So here, I want you all to understand the concept. Then later on, towards the end of the training, when we finish everything, we'll do one small exercise. I have a very small exercise for everybody. Different size column, okay, right? Okay, yeah. If no one is saying anything, then I'm going to assume that everyone is fine with this. You will have your chance to try it later towards the end of the training. Don't worry about that. If you don't know how to do it, maybe I can show you also lah. Show you 2 different columns, same thing again, right? Maybe I have a big column. Let's create a sample for you to see. Okay, I'm gonna do 1, 2, 3. So these 3 columns gonna be big. Actually, don't need 3, just 2. Okay, this one. So both of these columns going to be big. Let's say I put 1000 times 1000. And I copy this to the floor above. So I go to my first floor. I'm going to adjust, make sure that one of it is, okay, let me see. Let's say this one. Put the column 3 first. Okay, this one is going to be 900 mm times 900 mm. So this one is well over 75. This one is well over 75 offset. And this one is going to be 950 times 950. I'm doing this so that you all can see the differences, right? Okay. And now I'm going to calculate everything. All floors, 3D. Okay, the one that offsets more than 95. So it's this one. You can see that. Hold on. 1000. Okay, look at setting calculation rules. Okay, now you're going to see the offset values that are different over here. Let me delete the other columns behind first. Not very hard to see. So when we are trying to offset, we're trying to do apply those settings. You can see that when it exceeds the offset value of 75, it will actually bend in like what you see inside calculation rules just now, right? It will bend in. And then after that, the reinforcement from the top, I have to calculate this one first. Calculate first, because I only calculate one column just now. This one will actually plunge in. It will poke inside the column at the bottom. But the one at the right side one won't do that. It will actually just stop here, right? And then the reinforcement on the right column will go all the way up because the offset value is less than 75. So that's the situation. To just give you an insight of how it actually looks like when you're doing it inside the software, just to let you know, right? So it's different one. Make sure you understand this concept because you are going to apply this one day when you are working with the general notes, right? Okay, so for different size column, I think should be no problem. This is quite straightforward. Then let's go into the next one, regular links and spiral links. So a lot of people get confused with these regular links and spiral links when they're doing their circular column, right? By default, the software is always going to choose spiral link. It's always going to choose this type of spiral link. But that's not the case, you know. In the industry, sometimes, most of the time, when it's just a normal round column, like especially those car porch column, or those what do you call it, cantilever slab column on the side one, those generally small one, we won't usually use spiral links, but we use regular links. These are regular circular links, right? So in this particular settings is for you to adjust spiral and circular links. So first thing first, of course, by default, we're going to use calculate by weight. We're not going to calculate the reinforcement with other kind of things, right? So we leave it by calculating weight. Then after that, for regular links, for your links inside your regular reinforcement over here, the hooks are set to default, which is at 125 degrees, right? 135 degrees. So if you want to change, you don't want the hooks to be 135 degrees, you can just click the angle over here and change. It's totally up to you how you want to change it. But I wouldn't change the angle also because this is supposedly correct, unless otherwise your engineer have special cases for you to fill it in. right? So you can change the angle of the links over here. Method of calculating rings remain at calculating by weight. Okay, then after that, for spiral links, like I mentioned just now, if you are using spiral links, then it's fine. It's fine. You can have this type of situation. But if you are using circular links, you need to make sure that you change it inside the software, right? You make sure you change the type of links inside the software. You don't want to leave it at spiral link. You see, I just create a column, spiral column. A circular column. I just created this column, but this column is actually spiral link. We need to change this to circular link, right? Make sure you change this to circular link. Otherwise, you'll be stuck over there as spiral, and you will be wrong. The quantity will be much more than circular link, right? So make sure you change this. Very important. For regular links and spiral link, any question? This one I think quite simple, straightforward also. Very straightforward, right? If I don't see any questions or any doubts and anything, I'll move on to the next slide. Okay, then let's move on to the next slide. Surplus rebar. Now, this is a very, very commonly asked question. People always ask, Keen, how come my reinforcement bar actually protrudes out from the column below, right? You know, you have additional reinforcement bar that protrudes out. I don't know why. It's not supposed to protrude out or protrude upwards, right? People ask me this type of question a lot. So they ask me this type of question. Let me show you what kind of situation were they in when they were asking me these questions, right? Let me show you. Delete all the columns here first, too many things. So the question that they ask is like this. Okay, I have a column over here, ground floor. I purposely make one column over here. My situation is like this. I have two different columns. Column number 2. Okay, I'm going to clear all the links first so it's easier for you to see. Okay, now this should be done. Right, the commonly asked question by people is this. When I have a situation that looks like this, people always ask me, Keen, how come my reinforcement for my column looks so weird? They will say this. You see, how come my reinforcement at this part over here it stops, and then suddenly the rest of the reinforcement will actually anchor down into my column at the bottom. So they ask me this type of question, or vice versa, right? So here, my reinforcement, this one it actually anchors upwards, but you can see that the differences of the anchorage is here, right? My height of my four corner bars and my bars in between is very different. Why? They ask me how come different one? What kind of settings did I do? Or what caused this to happen, right? So generally speaking, this is the surplus rebar, which is caused by that, which means that what I'm trying to say is that if you have a situation where, okay, for example, let's say your lower column rebar does not detect any connecting rebar above it, right? The reinforcement bar cannot detect that there is rebar at the center. So at the top part, it looks like this, right? This is your upper column. Then after that, when you refer to your lower column, you can see that there is no reinforcement bar at the bottom over here, right? There's no reinforcement bar, the circle over here. So this point, it plunges inside is because there is no reinforcement bar at the areas over here. It's supposed to have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So the situation is, to the software, there is no way this column is going to hold on. So what it does is that it anchors into the column beneath when there is no reinforcement here. Same goes to what I showed you just now, the other one, right? For this one also same thing, right? By right, I'm supposed to have 2 reinforcement bar at the center or the top there. But there is no way that my reinforcement bar, if I have 2 bars over here at the bottom, it cuts off here. There's no way for it to cut off here. So the software will automatically read an anchorage into your column. So this is actually the surplus reinforcement bar. You guys understand what I'm trying to say? Can you understand what I'm trying to say over here? I hope you guys understand. If you don't understand, please let me know. Hello, anybody there? Okay, I hope you understand, but if you guys don't understand, please put inside the chat box so I can repeat again, right? It's actually very crucial. If no one is saying anything, I'm going to move on to the next item. Make sure you let me know if you don't understand. Okay, right? Right? Surplus rebar. Go to calculation rules, look for surplus rebar. So you can actually change the figure over here. So for example, if it is 2,000, then you just put 2,000. You can put 2,000 here also. Then you can see the changes. I recalculate, then you can tell the changes over there already. Okay, I put 2,000. So the surplus rebar plunge all the way up 2,000. This one also same thing, I put 2,000. It plunged all the way down 2,000. So settings for reinforcement bar that does not connect to each other is actually this one. Just to let you know. Okay, good. If you understand, then that's good. Then let's move on to the next item. Lab 1 versus Lab 2. Okay, this one is, a lot of people ask me this question before. Before I teach you all what does Lab 1 and Lab 2 means, can anybody tell me what's the difference between Lab 1 and Lab 2? Does anybody, do you know what does Lab 1 and Lab 2 do? Can anybody tell me? If you don't know, you just say don't know. Right? If you straight away say don't know, then I can straight away explain to you. If you don't say anything, I'll be waiting here to see if you all know what does this Lab 1 and Lab 2 mean. Okay, I'm just gonna assume that everyone don't know. I'm still gonna explain this Lab 1 and Lab 2 anyway. Okay, good. I like that you don't know, so I can explain to you. Thank you for saying that you don't know. Okay, Lab 1 and Lab 2, this thing is commonly asked. People always ask this question. Hey, my reinforcement bar at the current floor now is 12 mm diameter, you know. But then when I put my lapping as 40 times diameter, the figure is wrong. It is not 40 times 12, right? So the situation is, it actually follows the reinforcement bar's diameter at the top, which is 40 times 10. So now, that's why I'm giving you this example. Assuming your upper column main bar is 12 mm diameter, right? And your lower column main bar or your current floor is 10 mm diameter. So if you apply, let's say my current floor is at a lower column in bar, right? So this one is my current floor. If I want it to multiply by 10 mm diameter, I need to change these settings to lab 2. If I change it to lab 2, it will take 40 mm times 10 mm diameter. But if I change it to lab 1, it will take 12 mm times 40 diameter. So that is the situation. Let me show you what I mean by that inside the software. Okay. I draw another column over here. So this column, copy up there also. Now we have 2 columns. Okay, this column, let's assume I remove everything. I remove all the things, right? So make it easy, 40, 40, 10. 40, 10. And then the top one is 40, 12. Right? So when we do this kind of situation, in our mind, we always tell ourselves, okay, I want my my lapping from this reinforcement, right, from this column here to up here to be 40 times diameter, right? In your mind, you will assume that, okay, I will take 10 mm diameter times 40, correct? So that is what we are thinking. But the software by default follows lab 1, which means that it will actually capture this 10 mm diameter. I mean, it will capture the 12 mm diameter from the top, from the column at the top. So you need to bear that in mind. Okay, so this one is very important. You see, okay, let me go to the Anchorage lab here. I change first. The lab settings is type 2, 40 times diameter. I put 40 times diameter. So you see, by default, it's actually lab 1. By default now it's lab 1, which means that it will follow the diameter above. Right now I calculate. And let's look at the lapping settings over here. You can see that it says that the lap length of upper floor plus lap length with rebar in current floor. So you can see, hold on. I need to set default all the settings here first because I changed some stuff. Default, okay. (40 times D). Okay, you can see that the lap over here, lap with rebar in upper floor. You can see this lap with rebar in upper floor. Instead of taking 10 times 40, it is taking 12 times 40. So 12 times 40 is 480 ma. So that is the situation. We don't want that to happen. This is wrong already. So if we change to lab 1, you will notice this. Now you notice this. Okay, you remember just now I mentioned the column above, column below. Column above is 12 mm diameter. The one below is 10 mm diameter. So if 12 mm diameter means that it's actually 40 times 12, which is 480 mm. So this one is 40 times 10 equals to 400. We want to achieve this 400. So in order for us to achieve this 400, I need to go to calculation rules. And then I need to change this to lab 2. When I change this to lab 2 already, main bar lab value, I change this to lab 2 already. Close this. And then you recalculate, then you can see the differences over there. calculate. One, 0, 3, 8. This is not supposed to happen. Did I change anything? I didn't change anything, right? Create your project files. Colon. T10, 4010. Copy this to other flow. Times diameter TLL. Okay, 20 times D. Okay, 480, then we change this to lab 2. Should be able to get it to 400. Okay, it's not supposed to happen. column left 40 times D. No, something is wrong with this one. That's not supposed to happen. One moment now. I think I know why. Well, the calculation rules is correct already. There's another settings that is actually preventing this from happening. Give me a moment, let me check. Extension. Okay, never mind. We take a 15 minutes break while I check on this situation first. Because this is not supposed to happen. So I see you guys at 11:05. Okay, I see you guys at 11:05. Let me check on this first. Something is wrong because this is not supposed to happen. If you change to lab 2, this is definitely correct. If you change to lab 2, it's supposed to be correct already. Right? Okay, good. Okay, just noticed that I just noticed something. It wasn't the software's fault, it was my fault. I totally forgot about a concept because just now I was using the bottom column or the lower floor to have 10 mm diameter and the upper floor to be 12 mm diameter. So in normal construction, your diameter from the column below will not usually will not be smaller than one above. So that was the situation. Instead of having it as a lapping, it has become a surplus to the software. So the column at the top that was 12 mm diameter linking to the bottom 10 mm diameter has become a surplus, which means the lapping did not apply. That's why we couldn't get that right. So what I'm going to do right now is vice versa. Instead of the top to be 12 mm diameter, the bottom will be the 12 mm diameter and the top will be the 10 mm diameter. So the situation is that, right? So now when I calculate, I change already. It should be correct already. Let me do a calculation first. Okay, yes, it's correct already. Oh, I was wondering what was going on. So it was my fault after all. It was my mistake. I'm so sorry for the mistake. This is a silly mistake. Okay. Now you can see it's 480. Okay. Now you can see that this is 480 12 mm diameter. This one is for lap 2. This one is after I've changed to lap 2 already. You see, if it is lap 1, it will actually follow the column above. If it is lap 1, it will actually follow the column above. Now I recalculate again. It should be 400. Yeah, now it's correct already. So it's literally not the software problem, it was my problem. I forgot about the part where the diameter actually counts also. So up to this stage, everybody can understand. I mean, were you guys able to tell what was the issue over there just now? Because the problem about this was that, okay, let me show you. There is two columns over here. So the problem just now was that this column, the rebars were 12 mm diameter, whereas the column at the bottom is 10 mm diameter, which is something that we don't really see inside the construction industry, because usually when your column goes up, it should become lighter and lighter because it carries lesser load. So just now what I did was this. So all I need to do was just swap this around. It was able to capture it properly already after that, right? So if your diameter above is higher, what happened was that it actually captured as surplus rebar. This 12 mm diameter will become a surplus rebar, and then it will actually anchor down with the settings that I've taught you earlier on. The surplus function, this one that you see inside calculation rules. This one. So this actually applied just now, that's why. So you guys roughly understand what was the situation just now? Yes, okay, that was my mistake. I'm very sorry. I overlooked that part already. Okay, never mind. Let's move on to the next section. Chapter lab 1, lab 2, any other questions? This one I think should be quite straightforward, right? I think I should change this. This one should be 12, this one should be 10. Yeah. So if lab 1 means it's going to take 10, lab 2 means it's going to take 12. So I'm going to change this. Any questions for lab 1 and lab 2 so far? Are you guys able to follow up to this stage? If no one is saying anything, I'm going to assume that everyone is okay. All right, so if everyone's okay, then we move on to the next part. Foundation, starter bar. Now, I like to teach people this one because a lot of people ask me these questions. After I've changed all these settings already, I'm not able to split up my starter bar quantity. How am I going to split up my starter bar quantity and things like that? So, never mind, we go through one by one first. We have 3 types of calculation method, right? Let me show you inside our software. We have 3 types of calculation method. The first one is lab at FD. Second one is lab at FD floor top. And the third one is lab at FD top. And at the same time, your foundation floor top also, you have one lab over here. Practically saying, that, okay, if you are using the type A, you will have one lab over here. If you are using type B, your lab will be at the ground floor, on the top part, which means your starter bar will go all the way up until your ground floor. If you're using type C, which means that you will have two types of lab, right? You have one lab at your column stump, and you have another lab at your ground floor. And this can actually split your quantities also. For example, instead of this whole reinforcement tossed under column stump, what's going to happen is that you can actually split your starter bar quantity, your column stump quantity. So that's the situation. Now, let me show you what do I mean by that. I'm going to create I'm going to mimic three different settings. Let me delete everything first. I like to delete everything. Okay, let me mimic three different settings. This is going to involve ground floor. It's going to involve, what do you call that? Column stump, I mean the foundation floor, these two floors. So here, 1, 2, I think I put this further away a bit. Okay, so now I have 3 over here. Copy this to my foundation floor. So when I copy it to my foundation floor, this becomes a column stump already. Right, these 3 columns become the column stump. And then I would have pile caps acting as the foundation. Okay, now let's form the 3 conditions out. Let us form the 3 conditions out. The first 2 columns, I want to use type A. Right, so this one I'm going to use type A. Then these 2 columns over here, I want to use type B. Okay. And then this one, type C. So once I've done that, just press OK. And then let us calculate everything. Okay, now you should be able to see these 3 columns at different kind of reinforcement. Right? So I want everyone to create this first. Is your TRB open? Is everyone's TRB open? I want you all to create this condition, which means I have 3 columns at my ground floor, 3 columns at my column stump, at my foundation floor, and then 3 pile caps. Any size pile caps of column also can. So once you all have created already, I want you all to put a done inside the chat box so that I can continue to explain. Right? Go ahead and put a done inside the chat box once you're done. Create a condition, 3 columns at the ground floor, 3 columns at your foundation floor, and then 3 pile caps. Once you finish already, put a done there so I can continue, yeah? Finish, everyone? You guys drawn already? Drawn already, and after that change the calculation rule settings. Are you guys able to get the model out? 3 columns, 3 pile caps. If you have done creating it like this, just put a done, yeah, because I want you all to do it on yourself, this one, so that you can understand how does this starter bar work. Okay, if no one is saying anything, I'm just going to assume that you all have already done it, but you just don't want to talk only. But it's okay. If you are good, if you have any objection, you can tell me. Otherwise, I'll proceed now because we can't spare any more time sitting down here. Right. So I'm going to continue. Okay. Once we have already done this, you can see that there are three different. Actually, on the left and the right here, it looks the same, but it's actually different. There are three different conditions right now. Right. So the first one is using type A. As you know, we are using type A. So you got starter bar at the bottom. Then the second one is using type B. Your starter bar goes all the way up until the ground floor and then laps there. And then for type C, you actually have starter bar at the bottom here. And at the same time, you also have a different quantity reinforcement bar over here. Right? So you can see that there is two separate quantities, starter bar, and after that here also you have the reinforcement at your column here. Right? Now, once we have already checked this part already, but when we look into the quantity, you can see that the quantity has not been split. Right? I open the modeling. And then when I look at my column, you will notice that, oh, it just says that this one is, where is my starter bar and things like that. It also is actually quite difficult for us to get the quantity over there. So how do we actually get all this quantity together? I mean, separate it out, right? Quantity by category, okay. Column. So now the situation is this: I want to open up my set classification, right? Open up set classification. Under view quantity by category, open up set classification for column, right? Make sure all these are correct. And then here, I just need to open up my rebar classification, right? So you can see there is main bar, double bar, U-shaped bar, link, spiral link, hook, auxiliary bar. So all this information, I must open up my rebar classification. And then after that, I need to unmark this summarize into main bar. I don't want them to combine into main bar. So I need to unmark this summarize into main bar. And then press OK. After that, you will be able to see a double bar already. So this is the double bar quantity that is separated out. Right? So is everybody okay up to this stage? Is everyone able to follow? Amy is okay. Ken. All right. So you want me to repeat from the entire column, or you just want me to repeat the report part there? Quantity part. Okay. So I've already calculated everything. So just now what I did was that I go into quantity, view quantity by category, and then under view quantity by category, just press OK because I want to view everything. Okay. Here, I need to go into my column part. Press column. In order for you to activate double bar, main bar links separately, I need to go to set classification. Under set classification, make sure you're inside column tab, right? Open up rebar classification. Mark it, make sure you mark it. And then untick the summarize them into main bars, links, and auxiliary bar. The reason why we want to unmark this is because we don't want to combine everything together inside main bar, right? Because double bar is actually a main bar also, just that we want to separate it out as a starter bar. We want the quantity taken out separately out. So we unmark this and then just press OK. And you should be able to see your double bar separately. Is that okay? All right. What about the rest? Everyone can follow, right? Okay, I think everyone can follow. No one is saying anything. I'm going to assume that you guys are okay, right? If you are not okay, again, please stop me and you can ask for a recap. I'm more than happy to do a recap for you. Right? Okay, let's move back to the slides just now. So what we saw just now, a quick recap on what we learned just now is, if you are doing type A, you will get your starter bar at the bottom here. And your reinforcement in the column stump will go all the way up until your ground floor. Right? So the reinforcement bar up here will be categorized under ground floor, not your column stump. Right? So you have to be very careful with what you choose. And then the next one is type B. Type B is that your starter bar combines all the way up to your starter bar at the top part here. The what do you call it? The ground floor main bar over here. So it goes all the way up. And then the third one is you will have two separate quantity, which is the starter bar in yellow from foundation until the stump. And then after that, you have a main bar inside the column stump all the way into your ground column here. Right? So make sure you understand this situation. Each and every one of these plays a very different role. All right, links inside anchorage. On this one, it's very simple. It's just that you go inside your calculation rules, and after that, when you go into beam and slab, you can insert how many numbers of links you want it to be inside the beam or slab, or even the foundation. Right? So, for example, go into project settings, calculation rules, and then we go at the bottom here. You can see that, let's say if you have 3 numbers of links inside your beam and slab where the column connects, you just put 3. You can do this, right? Same goes to foundation. If you got 5, then you put 5. If it is a big foundation, you need to have 10 links, then you can just put 10 links. It's up to you, right? Then if you want to revert back to default, just right click on it, restore default. Restore default. Is that okay for links in anchorage? This one is actually very simple. Don't want to talk too much about this. Links in anchorage, okay, everyone? Okay. I need some response from everybody so that I can proceed. Otherwise, if I bluntly just go tempat like that, then nobody understands what I'm trying to say, and then it could be a waste of your time also. I don't feel good wasting your time if whatever I'm teaching is not helpful at all. Okay, if no one is saying anything, again, I'm just going to assume that everyone understands until you say that you can't understand and require a repeat or recap, right? So we move on to the next item, column general settings. So this general settings is what I mentioned earlier on just now, right? Your anchorage, section change, and then after that you have wall column settings, right? So the first one is basically all the anchorage in different position of your column. For example, your top part here, how you want your column to anchor when it's in the middle of a slab or beam, or how you want your column to anchor when it's at the corner, right? With outer bars and inner bars. Then we have transfer column. Then we have column that ends with no joints or anything. It's just a column that sits there that does nothing. Right? This is rare, but you still have this type of situation for aesthetic purposes. Right? So let me show you. Inside calculation rule settings, column, and then you scroll all the way down, you should be able to see this middle column. So when we say middle column, it actually means that this is your slab elevation view. This is your slab, and then after that, your column is like in between here. So this is called a middle column, right? So your reinforcement, basically what it does is that it will go up like that, up like this. So this one is middle column, right? But whereas for this outer bar, how to tell what is outer bar and inner bars is this. Okay, okay, how to tell whether it's outer bar or inner bar is this. Now you can see over here, this is your corner of the slab, right? This is the corner of the slab, and your column here is actually stopping at the end. So the edge will always act as the outer part, The edge will act as the outer part. And the inner side here will be considered as inner part. So this is how you categorize outer and inner bars. This is how you categorize outer and inner bars. And then we have transfer column. Now, transfer column also, this one is depending on your settings one, right? So this is your wall. This one is your transfer column. So how you want your transfer column to plunge up? So basically speaking, most of the time also we don't really adjust the transfer column. We use normal column, also good enough already, right? So, but if you're using transfer column, the category as transfer column, this is what's going to happen if your wall is sitting on a transfer column. It will actually anchor in your transfer column, but your transfer column will not go inside your wall. It will actually just bend on the sideways like that. So this is for transfer column. No joints is when your column is sitting down and there is no joints above, right? So when there's no joints above, this is what actually takes place. The top part will bend and curve in like that, right? This is how they actually bend in. So this is for no joints. Same goes to your bottom part of the column. You will have anchoring into the beam or slab, anchoring into the top of wall, anchoring into your pile cap or your foundation, rough foundation, whichever foundation that you are currently using. And then after that, you also have bottom of column which sits on your pile, which is quite rare. So I'm not going to talk much about that. It's quite rare. And we have core column. So if you change your frame column into core column, this is what it actually applies. But this one also we rarely use one. We rarely touch this. It's more onto these few items that we are always touching. Here until here, this one. And then bottom of column, just these three. So these are the things that we actually touch on. And after that, last one we have is section change. Section change, it depends on your reinforcement. Okay, say for example, now it's time for me to show you examples again. Let me show you examples again. Okay, I'm going to go to my ground floor. I'm going to make a fat column. Fat column. So this is a fat column, which is 1000 mm. Copy. First floor. So this size, I'm going to put it smaller, like 500. This is just to show you how it actually looks like. Move. Okay, say if you have a situation where your column on the floor above is actually sitting on another big column. So this is called section change. This is called section change. See the column sitting down here? So this has become section change. So what it does is that it will actually go to your project settings calculation rules. It will actually adjust based on the section that you see over here. Now, however, you need to understand this also. There are two types of condition of section change. One of them is where there is a connection between your slab or beam or anything else that's going through your column, right? So there are things that are passing through a column. What I did just now here was just two pieces of column. There is no other jointings between other elements, right? So this is actually categorized as no joint. So this settings is going to apply, right? This settings is going to apply onto your section here. So you can see if I calculate, The reinforcement is actually applying that. Right? So it bends in, it applies that. And after that, it anchors in as well. For this one, it also anchors in because it follows the settings of your calculation rules. So this is how you adjust your information over here. You can just double click on it, then you can choose whichever type you want. Maybe yours is not that hard. Here you can put, you can choose number 4. After that, you want to change the length. Maybe you want to put a specific length like 1500, something like that. Then after that, here maybe you want to put like 40 times D. You know, you can change all this information. So when you calculate the time, things will be different. Can you see that? So the length is different now. And just now this part here becomes 1005 already. Yeah. So up to this stage, is everyone able to follow the column general settings? Everyone understand how this general settings works? One more thing, for wall column is exactly the same as what you see above here. But this setting is just separate for you to do on your shear wall. It's the same thing from what you see above. Just that this is for shear wall or wall column, right? So up to this stage, is everyone able to follow? If yes, put a yes. If no, put a no. At least just give me a heads up on what's your progress right now. Okay, VB can follow. Nice. Amy, Boon Xiong. Are you guys okay? Gabriel, go. Kenneth. Leon, Luis. Okay, everyone can follow. I think this one should be okay, right? All right, good, good. Everyone can follow, then that's good. So practically speaking, that's all for column only. But of course, we have some small exercise lah. Now, if I ask you to change these 2 items, will you guys be able to do that? Will you guys be able to change this information? Okay, how about this? I give you like 5 minutes. I think 5 minutes should be more than enough. 5 minutes until 11:45 for you to change all this information here inside TRB. And then later I show you how I change it, and then you tell me whether you did it correctly or not. Right? So if you did it correctly, you just put correct. This exercise is just, I want to see how far have you, learned so far when dealing with this type of situation. Okay, so 5 minutes from now until 11:45. So later you let me know whether you all were able to follow it or not. So first thing first, what I want to do is I need to check this information first, right? It says that it's 75 kicker. Then after that, we also have a band bottom on your rough or pow cap. So what I'm going to do is go to TRB first. Calculation rules. Scroll downwards. Change anything. I'm going to go down where it actually bends into my pow cap or foundation. So here I also know it's 12 times diameter by default, which is correct. Then now I want to check again. Next, what do I need to change? 12 diameter is correct, 12 diameter is correct, 75. Then after that, this one is lapping, right? So I don't need to change. This one is double bar. Then after that, top of the bars, which is 12 mm diameter also. So at the top, you can see it's also 12 mm diameter. So we don't need to change any of this information. Right? So then the next one is the right side here, splicing. And here, I can see that this one is 75 mm. The offset value is 75, which is, I think it's the same also. So when you go inside your settings, you need to check the offset value. So you can see that it's 75, means it's correct already. Then after that, we also need to check the settings over here, LT, or you can say LL, for this part where it's actually poking down. So how to actually change this part? So what I would do if I want to change this part is I need to go down to my section change, right? So this is the thing that is actually poking down. Instead of 1005, now I'm going to put this one as LL. Because LT is actually, LT is referring to a table, right? To a table, but we don't have the table. So same case like this, we also have a table. So we're going to use LL. LL is going to bring you directly to your floor settings. Then after that, under your floor settings, you are going to change the column lapping here. So this one is where your LL leads to. If you put LL, it will refer to this information over here. So basically speaking, the whole thing over there, I only change one stuff. I only change one item, right? So the item is this LL only, that's all. Right, the information here, change to this one, and then I put LL. So apart from this no join, did anyone change anything else? If you didn't change anything, means you understand that, okay, these are the things that I don't need to change. This is actually just a trick question, because by default, everything you don't need to change, right? Just want to see whether you will try to change other stuff. So up to this stage, has anyone changed anything besides this no join section change? No? Yes? No? Okay, good. What about others? Phoebe didn't change me. She understands where she needs to touch. What about the rest? You guys understand where you need to touch or check? Okay, I guess no one's saying anything. So if you all did anything besides that, please let me know. At least I know where you're stuck at, and I can re-explain to you that portion, right? So at this point, I'm just going to assume that everyone's able to do it because you didn't say much, right? So now for this part, we have already completed column already. So once you have completed all the things that I teach you here today for column, you should be able to work on your project or on column. Doesn't matter what kind of general knowledge you get, this is more than enough to teach you already. I mean, yeah, it's more than enough for you to operate the software. Okay, now let's move on to the next chapter. Chapter 3, wall. Now, wall is slightly similar to your column. Why? Because you have certain items that is actually same concept with column 1. For example, like the staggering, and after that, for example, like this offset, and then lap 1, lap 2. Right? So it's actually the same thing because both of these are actually vertical elements, so more or less the same. But there are certain different things that you will see inside walls also. For example, more additional reinforcement and U-bar details, right? You don't see this inside column. But this is just to let you know. If you wish to change or you wish to add any more additional reinforcement and U-bar details over here, you can look for this item, right? Number 3. You can just go to calculation rules and then search for wall. And then from here, you can find this item over here. We got diameter or vertical, additional vertical bar. You can see that it highlights the corner, the end, and the junction. And also we have info of U-bar, right? So that's why we got 2 here, right? So how to key in the information over here? This is just an example. You can key in the number plus the diameter. For example, 4010, right? If you have more than that, you can put 6010, 6012, 60 14, right? 6020, up to you how you want to put in the information. So you can key in all this information. Then after that, we can also key in your rebar info for your U-bar, right? So if your U-bar is T10 at 200, you can just put T10 at 200. You can just put T10 at 200. Now, just a heads up, a note for you. Walls, we have a lot of type 1, right? If you are an intermediate user, you should know that walls, RC wall, we will have items such as horizontal bar, we have horizontal distribution bar, or vertical distribution bar, we have binder, we have hooks, we have additional horizontal bar, additional vertical bar, and other rebar. So we got a lot of things over here, right? So let's just say you have a situation where you are not using a horizontal distribution bar. Okay, let me draw out this for you first. Let's just assume that you are not using horizontal distribution bar. So by default, just now you can see that in my project settings, I actually have a U-bar already. So this U-bar will actually follow the diameter of my current wall, the horizontal diameter, right? If your horizontal bar is 12 mm, then it's 12 mm. Your U-bar will also be 12 mm. And the settings will be at the bottom here, which I'll show you how to adjust later for U-bar. Okay, so assuming by default you already have U-bar, assuming we are using this T12 at 200. Right, so we got information that looks like this. You will have U-bar towards the end. One here, one here. So this is the situation of your U-bar. But let's say if you are no longer using horizontal distribution bar, instead of using horizontal distribution bar, you have opt to use binder. Let's say you use binder over here, and you don't have any horizontal distribution bar. So when you put a binder, you will notice something, which is your U-bar will disappear. You can see that you have no U-bar now. This is because these settings for the U-bar and the vertical bar over here highly relies on the presence of your horizontal bar or your BRC. If you don't have BRC, or if you don't have this horizontal bar and you're using binder, your additional information or this particular setting over here will not take place. This one is going to be useless settings. It's going to just sit there and do nothing if you're using binder, right? So if you're using binder and you happen to have a lot of additional vertical bars over here, what you should do is to go into your TRB and put your additional vertical bar over here. If you have additional, if this wall you have 4 at the left side, 4 at the right side, additional bar, we should just put 40, 40, something like that. So when you calculate, this information will be generated inside here. additional vertical bar you can see, right? You got 8 numbers. So this is how the additional vertical bar works. If you are using binder, make sure you check this properly because it's actually very important. And just to let you know, you can change your binder one. Just now, what I show you is actually in links one. So your binder is actually links in shape. It's actually one link shape. But if your binder is like two long U bar that is connecting to each other or lapping with each other, then you can change to this. Calculation rules. You can go and look for your binder. Instead of calculate by link, we can change it to calculate by lap horizontal loops. So this is what you can do. Okay. So up to this stage, are you guys okay with more additional reinforcement and U bar details? If you guys are okay, just put an okay over there so I can proceed to the next slide. VB is okay. What about the rest? Everyone else okay besides VB? Okay, very quiet. So again, I'm going to assume that everyone is all right. I'm going to proceed to the next slide. If you all have any troubles trying to understand, please let me know. Okay. So this is the information that I was telling you just now. The additional information that we key. Now we move into the next one, right? They are moving into hooks and middle bars at corners. So hooks and middle bar at corners, this one is just a conceptual. You need to conceptually understand what's going on in these particular settings. Now, if you go inside TRB, you can look for these particular settings over here. So you go TRB, calculation rules, then you should be able to find the settings over here. So this is the one, number 5, right? So back to the slides. The first one is this round. Kind of easy. I mean, you guys get what's going on here, right? So just gonna straight away go into the method of calculating hooks and method of calculating middle bars at corner, right? So when you want to calculate hooks, the default setting is that it will actually just generate based on what you've keyed in inside your wall, right? The hook part here, it will straight away depend on what you key inside here, which is R6 at 600 times 600. But let's say if you want to change, you want to do your own manual settings, right? You can actually go into method of calculating hooks here. Just left click onto this calculate by default value. Press on the 3-dot button. So I'm going to go calculation rules and then scroll down. Click here. Press on the 3 dots button here. And then you can set calculate by spacing or calculate by area. By default, it's going to be calculate by spacing. So you can allocate your spacing for horizontal and vertical start. Let's say if it's 200 for horizontal, then you can put 200. Then if it is 200 for vertical, then you put 200, right? So this is what you can do for your hooks. But let's say if this is not what you want to do, you want to calculate by area instead of spacing, you can just go to calculate by area. And then if you say calculate by area means, okay, let's say if I capture this whole area, the software will automatically calculate 600 times 600, which means every 600, I will have one gap of reinforcement bar or the hooks over here. So this one is the method of calculating by area. But I don't want it to look like this bi-direction layout. I want it to be in a staggered arrangement, like what you see here, staggered arrangement. I can just select onto my staggered arrangement, right? So after I've selected on my staggered arrangement, you will notice that the dots are in the middle also, which means that instead of 600 times 600, between the 600 times 600, there will be one more additional hook. So that is the situation. S1 and S2 is different, right? So S1 600, S2 600. If you're using bi-direction layout, then it will not have another reinforcement in between. But if you are using staggered arrangement, it will have another reinforcement in between. Everybody understand this part? For this calculation method for calculate by area, can understand what's the difference between staggered arrangement and bi-direction? If you guys understand, put a yes. If no, just put a no. Okay, good. All right, then if you guys understand, move on to the next item. Method of calculating middle bars and corner. Now this one is very conceptual. Let me think, how do I put this? Something so conceptual like this, I need to find a proper way to explain to you. Just now, what I was showing was these hooks. So you can refer to the slides when I share to you towards the end, right? Calculate by spacing, and after that we have hooks. Calculate by area. So here you can read all this information inside the slides later. Now, just not the one that I was talking about, middle bars and corners. What does this middle bar by corners actually mean? So based on the slide that I'm showing you right now on screen, it's like this. If I have a middle bar, okay, this is my middle bar, the one is selected. Do I want it to follow my reinforcement bars on the inner side or the bars on the outer side? What it actually meant by this is because, this one, why it actually uses this is because when you go into TRB and the calculation rule settings here, scroll down a bit, scroll down. And after that, you can see that here, under the top wall, you have something called left bar and right bar, right? Or this one also same thing, outer bar, inner bar, right? So this is the thing that we need to understand. Outer bar, if you base on the slide just now, means that whenever my reinforcement bar is facing outwards of the location, like let's say this is the bend, right? This is the bend, it's bending like that. It's facing outwards, facing this direction, right? So this is going to be my outer bar. And then this facing inwards, right? Facing inwards is going to be my inner bar, right? Facing this part is going to be my inner bar. Everybody understand? Because I need you all to understand, only I can further explain. Can everybody understand the differences between inner and outer bar? Vice versa, if you flip it left and right or mirror up and down, also same thing. So this is something that you need to understand before we can go further. So Gabriel understand this is okay, good. Can understand, then that's fine. Okay. So I'm going to assume everyone can understand. Those that don't understand one, you just put a no. I don't see any no, then I'm just going to proceed. Right. So now you can choose for the software to follow either the inner bar or follow outer bar. Right. You want to follow the settings for inner bar or outer bar also can. So this is for when you have 3 different layers. Now in this case, like every default, you can see that there's only 2 layers. You can see that there's only 2 layers over here. Right, 2 layers. So when I calculate the wall here, it's only 2 layers. So what if there is 3 layers? That's the question mark. If there's 3 layers, the reinforcement in the center, you want it to follow inner bar or outer bar? So that's the question, right? So you can choose that. If you have 3 layers, you will surely have an inner bar and outer bar one. Now you can see for example, now I have 3 bars over here, right? So the center one, you want it to follow the inner bar or the outer bar? That's the question mark, right? So once you have selected already, then you're good to go. Then you know which one you should follow, right? So in cases like this, under calculation rules, usually depends on your drawing. This one really no choice, depends on your drawing. Otherwise, by default, it's going to follow the inner bar. So it's going to bend inwards instead of outwards, right? This reinforcement is going to bend inwards together, aligning with your inner side. Is everyone okay with this part? To choose either inner or outer bar? I'm going to assume that everyone's okay lah, because you all didn't say no, right? So no is like the keyword for me to stop and re-explain. Okay, slowly. Now, anchorage settings for top and bottom. Here comes the part where I need to explain a little bit to you, maybe show you a bit lah, right? So we have top wall, we have bottom wall, but this wall does not just sit there and then after that does nothing, right? It must anchor into another element like slab or beam or foundation or other things like that, right? So that's the situation. But the situation is this: you need to understand each and every one of the situation, right? Beams and slab is different from foundation. If you are using ground beams and rug, then this foundation is categorized correctly. But if you are using on beams and slab, but then you change inside the foundation here, then it's wrong. So we need to be very clear what are we actually choosing, right? Same goes to this situation. We need to know what are we actually changing, left bar and right bar. Say for example, if my left bar is 1000, let me change and do something more. Okay, let's say this one, right? I change to these settings. This one is 1000. Make it more obvious so you guys can see everything, right? My left bar is going to be 1000. Oops, 1000. My right bar is going to be 500. So how you know all these band? Let me show you how it actually works. Okay, let's say if I put a slab here, change to first. Let's say if I put a slab on top. So when you talk about calculation, it's all about conditioning. Like this one now, I need to show you based on condition, then only you understand what's going on. If I don't show you based on condition, you will get confused. So like this situation, I'm going to draw like that. Now, how to know which one is left or right? Very easy. On your keyboard, I need you all to press this button. Right, press this button. Then you can see the arrow coming up. Press this. Then you can see this arrow coming up. So this is actually called the directional button. When you click on the directional button, when there is arrow, it automatically tells you, okay, once the arrow comes out already, you need to put it into perspective. You are viewing from the arrow's perspective, which means I'm actually viewing like this. So, okay, my eyes is looking straight right now, and on my left-hand side will be, here. My right-hand side will be here. So this part you know already, no? Here is going to be your left side, no? The reinforcement here is going to be left side. Reinforcement here is going to be right side. Right? So I'm doing this because I want to show you that this is all very situational. So when I go into my RS column, then you can see on my left side, this one is right side or left side. I also forget which one I set. 500, 1000. Okay. You can see the reinforcement bar on my left side will bend in by 1000, right? So on my left side, again, I put straight point of view. Here's my left side, right? The reinforcement bar on the left side. is supposed to bend in. From left side, it's supposed to bend in like this by 1000. And then from right side, it's supposed to bend in by 500. So now, view in 3D. Can you guys see? $500, 1000. You guys understand the concept? Understand, huh? Okay, good. Again, always check the direction. If you don't know what's the direction on the keyboard, you need to press on the button. Then you can check the direction. Okay? All right, then if no question for this part, then I shall move on to the next part. Okay, so left and right bar I already explained to you already. Bottom, I think this anchorage should be quite straightforward. Same goes to the left bar in foundation, the right bar in foundation, also same thing, straightforward. It's just a repetitive item. Okay, then we go on to connection settings for colonials and wall junction. This one is a bit, it looks complicated, but it's actually not once you understand the concept, right? So it looks like this. It looks like this. So when you go into calculation rules, you scroll down, you should be able to see something that there's a lot of ding dongs here, right? But outer bar, inner bar, skewed intersection, T-joint, section change, bar change, right? Now you really understand what is outer bar and inner bar. You know how to categorize this outer and inner bar. So what's going to happen is that you need to know that here is where you adjust whether you want to have U-bar or not, right? So by default, you have U-bar. If you don't want to have U-bar, you just need to double click and then choose a section where there is no U-bar, for example, like this one. If you choose this one, then your U-bar will disappear. Right? You can see that the U-bar has disappeared. Same goes to inner bar here also. Change it. And then your U-bar will be gone. So this is for when you want to change, you want to remove your U-bar, right? But let me show you conditions like this. If you want to adjust your U-bar length, it's actually here, right? You adjust your U-bar length over here. So let's say if I put 1005. This one also I put 1005. And then all my U-bars will change if I change everything to 1005. Close this. And then when I calculate, you can see the U-bar 1005. Can you see that? 1005. So all these settings, you must be very clear. If you want to change U-bar settings, it's always at the bottom, right? At the bottom, under end of wall and wall to wall, there is a few. 1, 2, 3, 4. This is for U-bars, right? So practically, that's just about it for U-bars. It's very easy to change and alter anyways, right? Then after that, we want to go into a situation where you have a skewed intersection, or you want to say there is a, how to say, a slight diagonal direction location of your RC wall. So you want this to happen. Well, if you don't want this to happen, you can actually change the type of skewed, right? You can change the settings like here, whichever that is suitable to your drawings. Here, this one I'm not too able to show you because I don't have a sample drawing for this. But if you do have a sample drawing or you want to share with me also can let me know that I can show you directly. But I'm pretty sure it's actually quite hard to find this kind of information. This one I don't have. Same goes to your T-joint also. You have U-bar over here. If you don't want U-bar, you just change to this one, remove the U-bar. right? If you don't remove it, you are going to have this U bar. You can see that it's drawn over here. And then the length also, you can put 1005. So that's practically just about it. And then we have section change, bar change, right? This bar change is actually when you have two different RC wall connected to each other. For example, you got like RC wall that has two different diameter. Let's say the first RC wall is 12 mm diameter, then second shear wall, RC wall is 10 mm diameter. So when they're connected to each other, this is what it will happen, bar change, right? It will interchange or interconnect like this, whichever you choose. So quite straightforward also. Section change, this one actually same like column. This is exactly the same as column. So I'm not going to talk much about this section change part, right? And then we have, so it's just about this part only, end of wall, opening. So this is the settings for when you have opening on your wall. For example, let me show you. Let me create a bigger wall, bigger opening. Okay, so this is my wall. And then let's say if I have opening in between. So now I have opening over here. Actually, it's quite hard to see. Yeah, but you can see the reinforcement, the U bar over here. It's highlighted, but it's a bit hard to see because it's connected over there. But this is the U bar. When there is an opening, when it detects the opening, this is how it looks like. Okay? So far up to this stage, up to this part, everybody can understand. L corner, elbow corner, T junction, wall dimension change, different wall connection. Is everyone able to follow up to this stage? We finish this chapter 3 walls, then we can go for lunch. So is everyone able to follow this this part? Okay, Boon Xiong can follow. All right, if no one's saying anything, I'm going to assume that everyone's able to follow. Then we move on to the next slide. Binder. So this one is the one that I showed you just now, the plain in wall, the one to the end of your wall. Then when you anchor into columns, this is the condition of the wall when it touches the column, right? So you can change this if you want to. If you don't want to change, you can. Oh, just a heads up to y'all. You will see a lot of abbreviation like HC, BHC, things like that. So don't be panic. Don't panic when you see these kind of words, right? Because when you click that, actually there is a part where it teaches you. They will tell you that these are the support parameters, and if you don't understand what does this actually mean, you can just press F1. When you press F1, it will bring you here. Then you just type operation brief. And then here you can find all the information. You can see BHC actually means cover. Then after that, LAE actually means this one is anchorage. And LA also means anchorage, but E is with anti-seismic anchorage, right? So this is the situation. LLE also same thing, anti-seismic. But the one that we are using is non-anti-seismic one, right? So we have rebar diameter, LN. HB means denotes section of height of beam. HC means denotes support wave. So always come here to read. Okay, maybe I copy this and put inside for you all. You can straight away copy and save this link, then it gives you all the abbreviation. And then I know that people will have questions like, why you call concrete cover as BHC and not CC or something like that, right? I agree with you. You should call it CC because here in Malaysia, concrete cover is concrete cover. But the reason why it's called BHC because in Chinese, in China, we call it 保护层. So there are a lot of things that they direct translate from China into Malaysia. So please forgive us if you find it difficult to understand. So, but we have this help center where you can click on. I just shared inside the chat box. Just press that, then you can look at all the abbreviation meanings. Right? I hope that actually helps you. Okay, and then let's move on to the next one. Binder. This is the one that I mentioned to you just now. You can have two types of binder. One is by using link, which will give you a 24 diameter hooks or so. And then we have the second one, which is lap by horizontal, or a two U-bar that is lapping with each other, right? So this one is binder. So I already show you how to do it. You can just type it inside here under the binder section. Horizontal loops looks like this. Also under binder, but this one you need to change inside just now the settings where I show you just now. All right. For binder, everybody, I think don't need to explain too much. That part I already explained earlier on. So we move on straight to steel fabric lapping. Okay, when we talk about steel fabric lapping, a lot of people they put inside. I mean, inside our mind, steel fabric lapping or BRC is always in meter square. There are certain situations where people want to have the weight also because they want to check foundation, things like that. We totally understand that. So the situation is this: we have two types of situation. One is you want to calculate with lapping. The other one is calculate without lapping. Now, usually subcon will want lapping, but usually consultant they don't want the lapping. They want, unless otherwise the engineer draw out the lapping, then they measure it lah. But otherwise they don't need the lapping one. They just measure directly without the lapping. In the event if you need lapping, all you need to do is just fill up the lapping info over here. Because by default is 0. So if you want lapping, all you need to do is head to the top part here. Under the lapping here, you can put LL. LL means lap length, which actually follows your floor settings just now, whatever you have keyed inside your project earlier on. So if you put LL means lappings will be taken into consideration. Okay? For this part, everybody understand about the lapping? Quite straightforward, right? Everybody understand about lapping this part? Okay, good. Good. So the lap length is depends on your BRC size one, which is standard 2.2 times 6 meter one. So every 2.2 times 6 meter, you will have one lapping for the BRC, right? Just to let you know. Okay, this one is what I showed you just now also. Whether you want to have U-bar or not, yes or no, right? If you want to have U-bar, by default, everything, the settings that you see over here will already generate the U-bar for you. But in the event that you don't want to have those U-bar settings, you can just change to the bottom part, right? It does not, the part where it doesn't say that there is U-bar, you just change it to that one. Just look at the shape over here, then you know that there is no U-bar. It's just the horizontal wall bar. Okay, so that's the situation. You can change the settings like calculation rules under wall by wall. End of wall also same thing, not just wall by wall, end of wall also same thing. So that's all for chapter 3. So far up to this stage, anybody got question for walls, RC walls? Very simple, it's not that difficult. Any questions for RC wall? If there is no question for RC wall, I guess that we can take a break from here. And then after that, I meet everyone at 2 o'clock again. Is that okay? We can go and have lunch now and then see all of you at 2 o'clock. Okay, there's one question. Will the settings in wall apply to wall column? No. Wall column, the settings for wall column is all under column. You go under column, then you scroll to the bottom part here. You can see that there is a specific settings over here for wall column. So this one is specifically for the wall column or the shear wall that I mentioned earlier on. If my shear wall need U-bar, I can't use wall column to draw my... Okay, in the event that if you have a situation where you need to use U-bar and things like that, you can actually draw the U-bar inside wall column. Right? For example, here, let's say if I create a wall column, I create one wall column over here. Let's say, make it a long one so I can show it to you. I delete all the links so you can see. In the event you need to have a U-bar inside your wall column, you can actually just draw your... It's categorized under link, but it's actually U-bar, so you can just change it as... You can label it as U-bar. You can just draw it like this. Like this. So this one is your U-bar already, but you will also have to remove the bands also because your U-bar usually don't have band one, no hook. Then this one will become your U-bar. You can also trim and extend, up to you how much you want to trim. For example, you want to add another 150 mm, just put 150 mm like that. Same goes to the bottom part. Is that okay, Boon Xiong? Or if you want to use your, if you're happy to use your RC wall as shear wall also can. To me, it depends on how complex your drawing is. If they give you a schedule, like a shear wall schedule, then usually I use wall column to draw lah. But if they give you very basic settings, like they tell you the horizontal bar is T10 at 150, then the vertical bar is T10 at 200, things like that. If they say this kind of information, then I will use RC wall to draw because it's easier to use RC wall when I have this type of information. But it is easier to use wall column if they give me schedule, my shear wall schedule. Is that okay, everyone? Okay. Any other questions so far? If there's no questions, I guess we can take a break from here. Then we see each other at 2 o'clock again. Is that okay? All right. See you guys at 2 o'clock. Bye-bye.